The word cellulose comes from the French word for a living cellule and glucose, which is sugar. Building insulation is low-thermal conductivity material used to reduce building heat loss and gain, and reduce noise transmission. Cellulose insulation is plant fiber used in wall and roof cavities to insulate, draft-proof and reduce noise. History of cellulose insulation. Cellulose is among the oldest types of building insulation material. Many types of cellulosic materials have been used, including newspaper, cardboard, cotton, straw, sawdust, hemp and corn cob. Monticello was insulated with a form of cellulose. Modern cellulose insulation, made with recycled newspaper using grinding and dust-removing machines and adding a fire retardant, began in the 1950s and came into general use in the U.S. during the 1970s. The market for insulation increased following the oil embargo of 1973-74. The embargo caused energy costs for heating to skyrocket across the nation, which led to increased interest in energy conservation measures. Insulation gains significant national attention as a cheap and available technology to increase the energy efficiency of homes. In 1977, following a particularly severe winter, a tax credit was given for homeowners who installed insulation. While in 1976 there were roughly 100 cellulose insulation firms with 125 plants, by 1978 there were more than 350 firms with more than 500 plants. Cellulose insulation was produced locally by small manufacturers who purchased ready-to-operate machines and offered a cheap and easy low-tech production process. Other than some constraints created by a shortage of boric acid for use as fire retardant, cellulose captured an increased share of the market due to lower costs and its suitability for retrofits. Meanwhile, fiberglass and rock wool producers found it difficult to keep up with the demand for insulation from their customers. Due to complaints by retailers, contractors and consumers about price, safety and quality control problems, the federal government began enacting insulation standards beginning in 1978. There was a great concern that the growth in cellulose manufacturers was leading to improperly or insufficiently treating insulation against the threat of fire, even though reliable statistics on a national basis did not exist. This led to the Federal Consumer Product Safety Commission passing 16 CFR Part 1209, which set safety standards covering 4 product attributes for cellulose insulation only: settled density, corrosiveness, critical radiant flux and smoldering combustion. Another regulation passed was the A-OER value rule, placing clear limitations on the claims that manufacturing and marketing firms can make about their product. The effect of regulations by the CPSC put most of the small producers of cellulose insulation out of business. The costs incurred by increasing fire testing made cellulose more expensive, and the bad publicity helped decrease demand. They were either unable to meet the testing requirements or they merged with other small manufacturers. In 1985 the CPSC asked Congress to repeal the flammability standard after further studies. By 1991 only 61 cellulose producers still remained in the U.S. The fiberglass industry meanwhile benefited from most of the regulations passed by the federal government. The heavy lobbying by the more centralized fiberglass and mineral insulation manufacturers helped pass the tough fire standards for cellulose insulation. These standards were reinforced by technical bulletins published by the Mineral Insulation Manufacturers Association that promoted fire hazard claims against cellulose insulation. These claims were not independently verified, faced little scientific review, or were purposefully misleading and untrue. Currently cellulose insulation has increased again in use in the United States. Part of the reason for this growth are studies that suggest that cellulose may actually protect a building from damage in a fire better than fiberglass because cellulose is denser than fiberglass and doesn't allow the oxygen necessary to burn structural members. Several National Research Council Canada studies have backed these claims. Another major reason for the comeback of cellulose might be because of the increased interest in green building. Cellulose has the highest recycled content of any insulation material and also has less embodied energy than fiberglass and other furnace-produced mineral insulations. Manufacture. Cellulose insulation is often made by hammer milling waste newspaper. The newspaper is treated with chemicals, such as boric acid, to retard the spread of fire. Products: 4 major types of loose-fill cellulose products have been developed under a variety of brand names. These are generally characterized as dry cellulose, spray-applied cellulose, stabilized cellulose, and low-dust cellulose. These types are used in different parts of a building and for different reasons. Dry cellulose is used in retrofitting old homes by blowing the cellulose into holes drilled into the tops of the walls. It can also be blown into a new wall construction by using temporary retainers or netting that is clamped in place then removed once the cellulose has reached the appropriate density. This form of application does settle as much as 20%, but the stated value of the cellulose is accurate after settling occurs. In addition, a dense pack option can be used to reduce settling and further minimize air gaps. Dense pack places pressure on the cavity, and should be done by an experienced installer. Loose fill in walls is an antiquated technique of using cellulose in wall cavities. The home performance industry and its accrediting bodies support the dense pack standard of insulating wall cavities, which does not settle. This method stops the stack effect and convective loops in wall cavities. Spray-applied cellulose is used for applying cellulose to new wall construction. The difference is of the addition of water to the cellulose while spraying, as well as adding some kind of moisture retardant such as chlorine to prevent mold cultures. In some cases the insulation might also mix in a very small percentage of adhesive or activate a dry adhesive present in the cellulose. Wet spray allows application without the need for a temporary retainer. In addition, wet spray allows for an even better seal of the insulated cavity against air infiltration and eliminates settling problems. Wet spray installation requires that the wall be allowed to dry for a minimum of 24 hours before being covered. Stabilized cellulose is used most often in attic roof insulation. It is applied with a very small amount of water to activate an adhesive of some kind. This reduces settling and decreases the amount of cellulose needed. This can prove advantageous at reducing the overall weight of the product on the ceiling drywall, helping prevent possible sag. This application is ideal for sloped roofs and has been approved for 512 slopes. Low-dust cellulose: the last major type of cellulose insulation on the market is low-dust variety. Nuisance levels of dust are created during application of most types of dry insulation, causing the need for simple dust masks to be worn during installation. This kind of cellulose has a small percentage of oil or similar dust dampener added. This may also be appropriate to homes where people are sensitive to newsprint or paper dust. Advantages of cellulose insulation: thermal performance. The thermal performance of loose-filled cellulose compares favorably to other types of low-cost insulation, but is lower than that of polyurethane and polyisocyanurate foams. The thermal conductivity of loose-fill cellulose is approximately 40 MW-Mach, which is about the same as or slightly better than glass wool or rock wool. This DUS and Euro unregistered trademark T represent the whole picture of thermal performance. Other important aspects are how well the building envelope is sealed from air infiltration, convective air flows, and thermal bridging. Cellulose is very good at fitting around items in walls like pipes and wiring, leaving few air pockets that can reduce the overall efficiency of the wall. Dense pack cellulose can seal walls from air infiltration while providing the density to limit convection, when installed properly. The University of Colorado's School of Architecture and Planning did a study that compared two seemingly identical test structures, one insulated with cellulose and the other with fiberglass. The cellulose insulation lost 26.4% less heat energy over time compared to the fiberglass insulation. It also was shown to tighten the structure more than 30%. Subsequent real-world surveys have cellulose performing 20 to 30% better at reducing energy used for heating than fiberglass. Compared to closed-cell, polyurethane foam insulation, cellulose has a lower value per inch, but is much less expensive. Foam has a higher cost per equivalent of value. Long-term cost savings: annual savings from insulating vary widely and depend on several factors, including insulation thickness, original wall performance, local climate, heating-cooling use, air tightness of other building elements and so on. One installer claims cellulose insulation can save homeowners 20 to 50% on their utility bills. Sound insulation. Insulation reduces sound traveling through walls and between floor levels. Cellulose provides mass and damping. This reduces noise in two ways: it reduces the lateral movement of sheetrock and attenuates the passage of sound along cavities. Cellulose is approximately 3 times denser than fiberglass, providing a slight improvement in sound reduction. Mold and pest control. The borates in cellulose insulation provide added control against mold. Installations have shown that even several months of water saturation and improper installation did not result in mold. It is a common misconception that the mere presence of crude borates in cellulose insulation provides pest control properties to the product. While boric acid itself does kill self-grooming insects if ingested, it must be presented to an insect in both sufficient concentration and in an ingestible form in order to achieve insect fatality. Proper testing of products containing borates must be performed in order to determine whether dosage and presentation are sufficient to kill insects. Once tested, registration with the EPA as a pesticide is required before a product may be touted as having pesticidal capabilities in the USA. Fire retardation. The borate treatment also gives cellulose the highest fire safety rating. Many cellulose companies use a blend of ammonium sulfate and borate. Vapor barrier. A vapor barrier may not be needed with cellulose insulation. For example, recent studies have shown that air movement is the primary method by which excessive moisture can accumulate in mild marine climates such as Portland, Oregon, USA. An insulation that fills the wall cavity completely can help prevent moisture problems. Recommendations against using vapor barriers with cellulose insulation are supported by studies, even though they classify cellulose as vapor permeable. In addition, cellulose acts to distribute moisture throughout the cavity, preventing the buildup of moisture in one area and helping to dry the moisture more quickly. Cellulose manufacturers do not recommend the installation of a vapor barrier with cellulose. Most U.S. city codes will require a vapor barrier for any external wall. Most U.S. cities will consider an appeal of the requirement if proper reasoning is provided. In March 2008, the U.S. city of Portland, Oregon, approved an appeal to waive the requirement for a vapor barrier retarder when using cellulose insulation. The appeal can be viewed in the Portland Bureau of Development Services search form by searching for Appeal Idaho, 4996. Fundamental to any appeal is mentioning that recent studies show air movement is the primary problem for vapor, that cellulose is an effective barrier to air movement, and that cellulose acts to diffuse vapor. Disadvantages. Cellulose has a few disadvantages. As compared to other insulation options, the R value of 3.6 to 3.8 per inch is good but not the best. Cost per R value is good. Spray foam has many of the same benefits as wet spray cellulose, while having advantages in R value and rigidity and air sealing. Many spray foams utilize an environmentally harmful blowing agent, such as Innovate HFC, cellulose does not. Dust. Cellulose contains some small particles which can be blown into the house through inadequate seals around fixtures or minute holes. Installation expertise and building codes. In some areas it can be difficult to locate installers that are experienced with cellulose. An experienced installer understands how to correctly dense pack loose fill dry cellulose, how to best apply stabilized cellulose on sloped surfaces, and the proper time required for wet spray cellulose to dry. As with other non-BAT insulation, U.S. city and regional state building codes may not be updated for cellulose insulation. Homeowners should call the city to verify that the insulation will be approved, and it may be necessary to provide product specifications to the city. This is not difficult, and the installer and the manufacturer should both be willing to handle this process, saving the homeowner any true effort. Slumping. If improperly installed, loose-fill cellulose could settle after application. In some situations this could leave areas of wall uninsulated. With correct training in installation methods and quality control techniques, this is ruled out by installing to tested densities, preventing any future settlement. Weight: for a given O value, loose cellulose weighs roughly 3 times as much per square foot as loose fiberglass. Ceiling structures should be inspected for signs of weakness before choosing a material for insulating the ceilings of existing structures. Off-gassing: many cellulose companies use a blend of ammonium sulfate and borate for fire retardation. Although ammonium sulfate is normally odorless, unexplained emission of ammonia and a resulting ammonia smell has been found in some cases. Mold: there is some evidence of increased mold infestation inside buildings insulated with wet spray dense packed cellulose, especially when used with a vapor barrier. Environmental properties: recycled content: cellulose is composed of 75 to 85% recycled paper fiber, usually post-consumer waste newsprint. The other 15% is a fire retardant such as boric acid or ammonium sulfate. Cellulose has the highest recycled content of any insulation available. For example, fiberglass has a maximum amount of 50% recycled content. Low toxicity and environmental impact of raw materials: the non-recycled components of cellulose insulation are still environmentally preferable to the raw materials of most other insulation types. Unlike foam insulations, many of which use HFC or HCFC blowing agents which have global warming potential higher than that of carbon dioxide, cellulose does not produce significant gaseous emissions. Toxicity of the raw materials of insulation types is typically highest during manufacture or installation. Neither is a significant issue with cellulose. OSHA states that cellulose is a dust nuisance, requiring a dust mask during installation. This compares very favorably to the potential NIOSH cancer risk of fiberglass. Embodied energy: the embodied energy of cellulose insulation is the lowest of the popular insulation types. It requires 20 to 40 times as much energy to produce furnace-made insulation materials compared to cellulose. Cellulose is made by electrically powered machines while mineral insulation is made in fuel-powered furnaces, reducing this advantage to a degree, as electricity generation is less than 50% efficient. If electricity is sourced from renewable energy sources, the efficiency of electric production does not matter, as efficiency is not a precondition for sustainability. Cellulose is made with locally available paper, while mineral insulation factories ship materials and products over greater distances. Cellulose insulation uses borates for fire retardation. Borates are a non-renewable mine product. Insulation is green: all insulation helps make buildings more energy efficient. Using cellulose insulation can contribute to obtaining LEED credits in the U.S. Green Building Council certification program. It can earn credit in 2 categories: the Energy and Atmosphere Energy Performance category and the Materials and Resources Recycled Content category. Product safety: cellulose insulation can be very dusty during installation, and it is recommended that a standard dust mask be worn while working. There is slight concern over the off-gassing of ink from the newspapers, but the material is sealed behind walls, and no studies have shown this as an issue. References. External links: the Cellulose Insulation Manufacturers Association, the Australian Cellulose Insulation Manufacturers Association, Bob Weiler, Beach House Cellulose Installation Video, This Old House, Retrofitting Cellulose Insulation Video. Is a vapor barrier needed for a cellulose-insulated home? CIMA Technical Bulletin No. 2, Standard Practice for Installing Cellulose Building Insulation, further reading.